In this video, I wanted to talk about some of the details of clutch operation, and as you can see from this illustration, the function of the clutch is really to couple the rotation of the engine crankshaft with the rotation of the input shaft of the transmission. So this is a transmission right here. You can see that the outer clutch basket, which is this thing right here, is geared to the crank. Now, there's a little bit of a difference here, because in this particular case there's an idler, and the reason the idler is provided is because the crankshaft here rotates backwards. In this motorcycle, the crankshaft rotates forward, so this gear is eliminated. So essentially you just have a direct drive between this gear and this gear, and as you can see, if you look inside the case, right here is this gear, and this gear you can see a little bit farther in right there. So basically they're counter-rotating gears. So when the engine rotates forward, this outer basket rotates backward. And so if we go back to this drawing, we can see that if the rear wheel is rotating forward like this, that means that the output shaft of the transmission is going to be rotating forward or clockwise, and then the input shaft of the transmission is going to be rotating counterclockwise. And you can see that's exactly what's happening there. So you can see that the input shaft is rotating counterclockwise. The function of the clutch itself, and this is a clutch pack right here. So the function of the clutch is basically to provide on-demand coupling and decoupling of the crank and the input shaft of the transmission. So let's talk about the clutch pack here. And one thing I wanted to address, I mean, it's pretty clear that these springs are basically pulling these two plates together and providing friction between the clutch plates, right? So if in this orientation or in this position, the outer basket is going to be coupled with the input shaft of the transmission, right? Because the input shaft couples to the clutch center right here. What I wanted to talk about is what happens when we pull the clutch lever in. The clutch lifter rod pushes this assembly in. What's going to happen is these plates are going to spread. The pressure plate is going to move back somewhat, and there's going to be some gap between the plates. But one thing you want to keep in mind is this is a wet clutch, and there's a lot of stiction between these plates. So in some cases, and I'm sure you've heard of cases where you pull the clutch lever in and the clutch doesn't disengage. So what I wanted to kind of demonstrate is what happens when we're actually using the clutch lifter rod to push this assembly in and release the pressure on the plates. So I'm going to simulate this pushing by just releasing the springs. And you want to do it gradually. So now you can see that this plate is completely free, and these plates are still stuck together. And so the reason this is happening is you may recall that there is a judder spring that's sitting on the friction face of the clutch center or the inner hub, and this friction and this judder spring is actually pushing. So the judder spring clears this fiber plate, and it's pushing on the metal plate that's next to it. So essentially it's shoving all these things, all these plates together, and this one is free. But the interesting thing is, so the judder spring is supposed to eliminate vibration in the clutch pack, and I'm sure it does that. But another thing that it does is when you're pulling your clutch in, it's actually the first thing to kind of break at least this plate free, right? So it has another one of these functions. Now, right now, it's pretty much the judder spring that's forcing these things together. So let's loosen the pack some more. Okay, so after loosening it some more, you can see that we can move these plates a little bit. This first fiber plate is completely free. Let's keep going. Okay, so at this point the clutch pack is free. But let's remember, you still have, you know, in operation there's going to be a bunch of oil there. And a lot of the other systems that I've seen actually have little springs that are meant to separate the plates. Here, we don't have that. So let me take this thing apart and maybe we can talk about some other features of this clutch that help prevent drag. And let me take all the plates out. This is the in direction into the engine. So you can see that the clutch pack is supposed to be just here between the pressure plate and the inner hub. And this is how much your clutch actually moves when you pull the lever in. So it's not a whole lot at all. It's maybe about 3 millimeters or something like that. And interestingly enough, if you take this measurement right here, right? And then you look at the wear patterns, they correspond exactly. And the same thing is true if you look at the wear patterns on the outer basket. So this way you can see that this is how much the plates are moving when you pull the clutch lever in and out, just this much. And that's why really when you see these wear patterns like that, it's not that big of a deal, because I think maybe some people have the idea that as the clutch is being actuated, the plates kind of move across all of this. They do not. They just travel a very small distance. Again, like I said, each plate just travels within its little designated area, which is about 3 millimeters wide. With that out of the way, what I wanted to show you is also this, which I find to be very interesting. Let's look at the inner hub. And we're going to take a small hole gauge, and I already set it, right? But you can see that as you run this gauge down this channel, it passes all the way through. There's no play here, there's no play here, which is telling me that these channels, the sides of the channel, are parallel to each other. Okay. Now, if we take a similar, it's a telescoping gauge, and look at the outer basket, you can see that the gauge fits in no problem here, but as I keep inserting it, it's stuck. And if you go over here, it doesn't even fit on the top. Like here, you know, passes right through. Here it doesn't fit. And it's not an aberration. All of these things are like that. And so you might wonder, why did they make the outer basket with the fingers that essentially diverge? And I think the reason for that is exactly what we're talking about, is when the clutch lever is pulled in and the clutch is disengaged, you might need to have some additional means to break the stiction between the plates. And these means are essentially having, so the metal plates are sitting on the clutch center, and these channels are straight, and then the fiber plates engage, so these are the drive plates, these are the driven plates. The fiber plates engage the fingers of the clutch outer basket, and when there's relative motion between the two, and there's always relative motion, right, because this thing is going to be moving at a different speed than this shaft, you're essentially going to have shear between the metal plates and the fiber plates, but all the metal plates are going to stay in line, and the fiber plates are actually going to kind of stagger. So I think the reason they designed it this way is that to introduce a small force just to help the clutch disengage.